All right, hey there, y'all. It's Miss Campbell. I'm going to be going through some problems on the review with you guys. And then the other ones you're going to work out on your own. And then you can check it with the key to see how you've done. So the first one I'm going to do is number 2. Okay, on this one here, it's just combining like terms. So essentially what we're going to do is we're going to go through and we're going to look at the variables and the exponent and see if those terms go together. So remember, like terms have the same letter, the same variable, raised to the same power, the same exponent. So the first one here, I see I got x squared, right? It's 3x squared. So I'm going to look through all the other terms here. I have a negative 5x, a positive 1, a negative x squared, a negative 4x, and a positive 7. I'm going to see if anything else has an x squared on it. Okay, so I see here, I got this x squared. So this 3x squared and this negative x squared, those can go together, right? Because they both have x squared. So I got 3 here, and then this one, you see it's negative, right? So it's really like negative 1. So 3, you're going to do 3 plus negative 1. And so 3 plus negative 1 is 2. So we have 2x squared. Okay, so that's our x squared terms. And then the next thing that we're going to look at is the x term. So here I have a negative 5x, and I go through, okay, and I see a negative 4x. And those go together because they're just x's. So negative 5 plus negative 4. So that would give you negative 9. So you would have negative 9x. And then finally, the last kind of terms we have are constant terms. So you would combine those. We have a positive 1 and a positive 7. So you would do 1 plus 7, and that's 8. So plus 8. And then that would be your answer. Okay. Okay. Next problem that I wanted to go through would be number 7. So we'll go down here to number 7. Okay, and I'm trying to go through kind of like one type of every problem that's on the review so that you still have some that you can practice independently. And again, we're going to put the key up so you can check your work, make sure you've done it correctly. All right, so first thing here, we see we've got 2 sets of parentheses, right? And we have a number in front of each set. In front of the first one, I've got 1/2. And in front of the second set of parentheses, I have negative 1/3. So when you see numbers in front of your parentheses, you're multiplying that in to the coefficients of every term. And then after we do that, we'll combine like terms. All right, so this first one, we're going to take this 1/2 and we're going to multiply it in to each of these. So we're doing 1/2 times 2 for this b squared, right? So what's 1/2 times 2? It's 1. So I'm going to get 1b squared. Then I'm going to do 1/2 and I'm going to multiply it by positive 6. And so 1/2 times positive 6 is 3. So I have plus 3. Okay, next, I'm going to take negative 1/3 and I'm going to multiply into each of these terms here. So I'm going to do negative 1/3, and the first term is 6. So negative 1/3 times 6 would be negative 2. So I'm going to put minus 2. And then I'm also going to do negative 1/3 times, and I have a positive 9. So negative 1/3 of 9 is negative 3. And we got b squared, so minus 3b squared. Okay, so we've done the distributive property, gotten rid of the parentheses. Next thing that we will have to do is go through and combine like terms. So we can see that we have a b squared and then this negative 3b squared. So you would do 1 plus negative 3, which is negative 2. So you will have negative 2b squared. And then finally, we have these constant terms here. We have a positive 3 and we're going to add a -2. Okay, whenever you're combining like terms, you're always adding them. And then you just use the signs here to say if I'm adding a positive or a negative number. So 3 plus -2, that would give us 1. And it's positive, so +1. So this would be our final answer. Okay, my next question that I will go over with you all is number 8. And going over number 8 is going to help you on questions like 6 and 5, okay? So number 8 here. All right, again, we see we've got parentheses, right? Okay, anytime you've got parentheses, you're going to be multiplying numbers inside. In front of this first set of parentheses here, remember there's really a 1 right there, okay? And then we see this subtraction, right? Okay, we're taking this first polynomial and we're subtracting the second polynomial. So in order to do that, we're going to remember that this is like a -1 in front, and we are really multiplying a -1 to each of the coefficients of these 3 terms. So we're going to multiply the numbers in, and then we're going to combine like terms. So we're going to do 1 times 3, which is 3. And then we're going to do 1 times -6 into the 5th. So that's -6 into the 5th. And then we're going to do 1 times this -8 into the 4th. So multiplying anything by multiplying anything by 1 just keeps it the same. So whenever you're adding or subtracting polynomials, just remember this first set here, as long as there's like a understood 1 there, everything in it stays the same. Okay, now the next one. Again, we said we're subtracting these polynomials, right? So we have to multiply this -1 into everything in here. Okay, and if you multiply something by -1, it becomes the opposite sign. So -1 times -6 into the 4th will become +6 into the 4th. -1 times -3n will become +3n. And then -1 times -8 into the 5th will become +8n to the 5th. So we've taken care of the parentheses, multiplied all of the numbers in front into everything there. Now we're going to combine like terms. My first term I have is 3. It's just a constant. So I'm going to go through and look. Do I have any other constants to combine with it? No, so it's just going to be 3. Okay, the next kind of term I see is n to the 5th. So now I'm going to look at the ends of all the different terms. Okay, I'm going to look for another n to the 5th. Okay, the next one has n to the 4th, same letter, but different exponent, so it can't combine with it. Same thing here. This is another n to the 4th. It's not going to combine with n to the 5th. Here, this one's just n. Okay, but on the end, we have an 8n to the 5th. So those can combine. So in my calculator, I would do -6 plus 8. And -6 plus 8 would be 2. And it's positive, so plus 2, and then it's n to the 5th. Okay, next terms, I have our n to the 4th. So I have a -8n to the 4th and a +6 n to the 4th. So those can go together. So I'll just add their coefficients. So -8 plus 6, and that's -2. So you have -2, and those were n to the 4th. Okay, and then lastly, I can see the only thing I have here, and I'll just put them in a little like heart shape. The only thing I have there is a 3n, a +3n. There's no other just n term, so he's just gonna go down here. All right, now, as far as making this the proper answer, like in the proper order, we just have to follow, remember, highest exponent to lowest exponent, and then any constants go at the end. So my 2n to the 5th, that's going to go first, okay? Then I'm going to have -2n to the 4th, and then I would have this +3n, and then finally this 3, the constant's got to go on the end, so +3 because it's positive. And there's your final answer. Okay, next kind of problem I'm going to go over. I'm not going to go over the entire problem, but I'm just going to give you a little hint, a reminder, is like on number 9. Okay, anytime that you see parentheses, you gotta take care of those first. So on number 9, okay, this negative 4k to the 4th, that's good, there's no parentheses. This plus 14, no parentheses. But here, we see this parentheses with the 3k squared minus 3k to the 4th, right? Well, what's in front of it? A negative 1. So on problems like this, we have parentheses in the middle. Step 1 is to multiply whatever number is directly to the left inside. So first step is going to multiply everything in here by negative 1. So I'm just going to rewrite and then y'all can finish it out. So you would have negative 4k to the 4th plus 14. And then we're taking everything inside the parentheses and we're multiplying it by the number right in front, which is negative 1. So negative 1 times positive 3k squared would be negative 3k squared. And then negative 1 times negative 3k to the 4th would be positive 3k to the 4th. And then those parentheses are gone now. And then we just put here the minus 14k squared. Okay, and then from here, y'all can finish this. Just combine like terms and then make sure you write the answer with your highest exponent term, like variable term first, all the way down, and then your constant at the end. Okay, next topic, domain and range. Remember, domain is the x values and range is the y values here. Okay, so the domain, we've got a scatter plot here, right? So what I want to do is I'm going to go and find the ordered pairs for all of these points first, and then I'll go and look at my x's and my y's and get my domain and range. So this first point, okay, y'all, you go find the x coordinate. Okay, what's the x coordinate? Negative 3. And then we go to the y coordinate. Where does this cross the y-axis? At negative 4. So this is at negative 3 comma negative 4. All right, my next point looks like the x is at negative 2 and the y is at 5, so negative 2, 5. Okay, this next point here, I'm going to go with the higher one here. This is at 1, 3. And then the one down here is at 1, negative 2. All right, so domain. For my domain, I'm just going to get all of the x values. Okay, and you're going to go from least to greatest. So you're going to start going from the left to the right. Okay, so for domain and range, starting from the left. Okay, so my furthest left point is over here. I'm just going to look at the x values from it. So negative 3 is my first one. Okay, and we're making a list of the x's and the y's because we have separate individual points here. Okay, so negative 3, and then the next farthest to the left point is this one up here. So the x value there is negative 2. Okay, keep going. We have 2 points with the x value of 1, so I'm just going to list that once. And then actually, I forgot this final point here. This point, the x is 4, and then the y, you see how it's on the x-axis, so the y is 0. So our farthest right point, the x value there is 4. So that's our domain. So that's all the x's of the points on our graph. Now the range is going to be all of the y's. So again, we want to go from least to greatest. So I'm going to start with my lowest point and then work my way up because the y's go, the negatives are down bottom and the positives are up top. So my lowest point, the y value is negative 4. Next highest one is negative 2. And I'm looking at the y's. The next highest one is 0. Next one after that is 3. And then finally 5. So that's my domain and range when you have a scatter plot. Okay, so we got a couple more that we're going to go over. The next one, okay, is going to be on the next page. Okay, right here. I'm going to do number 13, and this is going to help you on number 12. All right. Or actually, let me do 12, not 13. 12 is a little bit more interesting here. All right, so domain and range. Okay, again, domain, you're finding all the x's that your function takes on. And then for the range, you're finding all the y values that the function takes on. So now this one, you see how it's a nice connected line, right? Okay, this is continuous. This is a continuous function. So we're going to have to give our domain and range as inequalities because there's a range of values there. We can't list out every single one. So for domain, you're going to start on the left and then you're going to look to the right and you're only looking on the x-axis. Okay, you're just looking at the numbers on the x-axis. So the domain is on the x. All right, so look at your graph here. Keep going. How far to the left? What's my furthest left point? It's right here, right? And so just go up. What number does this cross on the x-axis? It crosses at -4. So for my domain, I'm going to start at -4. And then I'm going to put a less than. And we need to determine, are we going to leave it as just less than, or are we going to leave it as less than or equal to? So look at the circle right here. Do you see how that circle is filled in? That means that it can actually be equal to this point. So our x value could actually be -4. So we're going to have to put less than or equal to. Then you put the letter x, okay? And for domain, you always go left to right, okay? So the number on the left is the x value farthest to the left. And then less than or equal to because we had a closed circle. Now we keep going, we look at our graph. Okay, we're keeping going to the right, farthest to the right. Oh, right here. This is my farthest right point here. So I go and I look down at the x-axis. How far to the right do we go on the x-axis? To 3. And then I need to determine, do I want a less than or a less than or equal to symbol right here? So I look at the circle. Remember, you see here, look, this circle is open, yes? So the graph is telling you I'm going towards this point, but I don't ever actually reach that point. So it's not going to ever be exactly equal to 3. So we just have to leave it as less than. So remember, an open circle is just less than. A closed circle is less than or equal to. So that's domain. Domain is looking left to right. Now range, okay? Range, you're going to look bottom to top. So we're going to look and we're going to see, okay, what is my absolute lowest point that my graph goes on this y-axis? And it's right down here, yes? Okay, at -5. You see it's crossing the y-axis at -5. And if you'll notice, you see how the line is solid connected here, yes? So that's going to be like a closed circle. So we get our bottom value here, and it's on the y-axis. So when you're doing range, you're looking just at the y. So -5. And we said it's a solid line there. So we're going to use less than or equal to. And then we're going to put y, because that's what range goes with, is y. And then we're going to look, okay, where are the highest points on our graph and where do they cross the y-axis there? Like what's their y value at those points? So you can see it goes all the way up here, like this is the highest point. And so is this guy here, right? Our open circle. And what y value do both of those have? They both have that y value of 5. So the highest on the y-axis that my graph goes up to is 5. And again, it's a solid line over here, right? Okay, so since this one is solid, I know this guy over here is open, but since you have at least one solid point there, it's going to be less than or equal to, I have 5. All right, so then use that information to help you on number 13. Couple more. Next one we're going to look at is number 15. Okay, this one, y'all, is really simple. Domain and range. Domain, you're just going to get the x's. Range, you're just going to get the y's. So what's my domain? Let's see, -1, 14, -3, 8, 2. Okay, -3 is my smallest. Then I got -1. Okay, and then what we got, 14, 8, and 2. So 2, 8, 14. So that's my domain. It's all the x's. Now the range is just the y's. And again, we're going to list them least to greatest. So I go and I look at all my y's. So far, the smallest one I've seen is 0. Okay, -2, -3. So -3 is my smallest. Then I got -2. All right. Okay, what's my next smallest after that? It would be 0. and then 4, and then 12. So that's how you do it when you have a list of ordered pairs. Okay, last two. All right, 17. It says a farmer must add the areas of 2 plots of land to determine the number of seeds to plant. The area of plot A can be represented by 3x squared plus 7x minus 5, and the area of plot B can be represented by 5x squared minus 4x plus 11. So write a polynomial that represents the total area of both plots of land. Okay, guys, total. Total means to add. So you're just going to take your 2 polynomials, so 3x squared plus 7x minus 5, put that in parentheses because that's the first one, plus, and then we got the second polynomial, so it's 5x squared minus 4x plus 11, and then we just add them. Okay, remember when you're adding, none of the signs are going to be changing in here, so we're basically just combining like terms. So we can rewrite 3x squared plus 7x minus 5. And then here, technically, you're multiplying a positive 1 into all of these. So plus 5x squared minus 4x plus 11. And then we just combine 3x squared, 5x squared. So that's 8x squared. And then we would do a 7x together with the negative 4. So 7 plus negative 4. That's 3. So plus 3x. And then finally, your constants, you have a negative 5 plus 11. So that would give you 6. So plus 6. And then check, is it in order x squared, x constant? Yes. So that's your answer. Again, why did we add them? Because it said total. Okay, total area. And then finally, the last one. Number 19, perimeter. Okay, they want to know the perimeter of the shaded region. Well, we got a small rectangle and a big rectangle. Okay, y'all, perimeter. Perimeter is the measure of the outside edges, yes? Okay, so we got to make sure that we know all the edges before we start adding them up. So this one here on the bottom is 2x plus 5. This one here along this side of the rectangle is 6. So guess what? It's got a matching one over here. This is also 6, right? Okay, and then let's look at our small rectangle. We got this upright side is 3, so this part over here is also going to be 3, yeah? Okay, now here's the big question. What's this piece right here? What's that part? Well, we're going to actually have to find the difference, yes? Because we don't want the whole side of the big rectangle, right? We have to get rid of the length of this smaller part, don't we? So what's the length of the whole big side of the rectangle? 2x plus 5. But we want to get rid of, take away this smaller piece. And remember, the smaller piece is going to be x plus 2, because that's what it is up here. So basically, we got to do 2x plus 5. And then we want to subtract. Now, what do we want to subtract? X plus 2. So since we want to subtract that whole thing, we got to put it in parentheses. And then now we will subtract here. So we would have 2x plus 5. And then remember, subtracting means to multiply everything in the second set by negative 1. So just change the sign. So x will become negative x. Positive 2 will become negative 2. And then we combine like terms. So 2x minus x is x. And 5 minus 2 is positive 3. So this piece right here would be x plus 3. And so now, and I'm going to kind of help you set it up, but y'all got to finish it out. Now what you got to do to find your final answer is just go and add up all the little pieces, right? So I'm going to highlight those in blue. So you would add a 6. You would add a 2x plus 5. You would add another 6. You would add a 3. You would add an x plus 2. You'd add a 3. And then you would add an x plus 3. So add up all of those and then combine like terms, and then check your final answer with the key. So just remember, perimeter means to add up all of the edges. The only tricky thing in this one here was the fact that we had to find this extra little bit, but we knew the whole length of the big rectangle and we knew the length of the small rectangle. So we just found their difference to find what this extra bit was. So adding and subtracting polynomials there. All right, guys, good luck. Check your answers with the key and we'll see you later.